These two tanks are from the Sphere's slosh experiment, which we've been working on up here.
Microgravity has a lot to teach us. Take these containers. The green liquid inside is showing us how fuel swirls around in a tank while it moves through space. What we learned could help us design safer, more efficient spacecraft. At any given time, we are conducting close to 300 different experiments aboard the International Space Station. Research like this is preparing us for the future of space exploration.
That's cool.
We really can't mimic the environment on the space station anywhere on this planet. And it's what makes it such a special place and why scientists from many universities, several companies, like to send their science up, because once you remove gravity, many things act differently.
This season, we're exploring why we send science to space and what it takes to get it there. Spoiler alert, you don't have to be a rocket scientist to conduct research in microgravity.
So this is our first project that is going up to the station, and our first project working with anyone involved in the space program. So it's a very exciting time for us. The transition from what am I going to do with my life in the middle of graduate school to here I am sitting in Houston getting ready for our launch. I can't hardly believe that it's actually happening.
Meet Elaine, one of the co-founders of Tympanogen, a medical device startup based in Virginia. Her company is developing a gel patch that can serve as a replacement for eardrum repair surgery. That could have huge benefits here on Earth, but launch that gel to space, and the opportunities for use grow even more. First, we have to back up a few steps. Putting your life's work on top of a rocket may seem like a daunting task, but there's a system in place to help scientists who know nothing about spaceflight get their research into orbit. You see, NASA and its international partners aren't the only source of science aboard the space station. The ISS U.S. National Laboratory creates pathways to space for companies, universities, and even young students. If you're starting a journey into the unknown, it helps to have an expert at your side to navigate the way. The National Lab connects researchers with implementation partners who provide resources and guidance for taking an experiment from Earth to microgravity. Elaine and her team are working with nanoracks.
They have the plate reader on the space station that's going to be used for our project, and they're coordinating the launch and getting all the materials together for us. We're glad that we're working with them because we're glad that somebody has done this before and can help us along with the process.
7,643.
The project that we're sending to the space station is looking at how hydrogels behave in microgravity conditions, and we're specifically looking at how the structure changes and how drug release profiles change in the absence of gravity.
My name is Paris Du. I'm a co-founder and co-inventor of this technology, and I've been with Tympanogen since day zero. Hydrogels are a very important materials. They are high volume water that can very well mimic the extracellular matrix of our body. So we really thought that answering this question can really help the scientific community.
Confused? Don't worry, we've got you covered. Think of hydrogels like a scoop of gelatin. Not quite a liquid, not quite a solid, definitely made up of mostly water. We can use hydrogels to cover wounds and even deliver antibiotics to promote healing. For that reason, hydrogels are being studied for use for things like wound care for soldiers on battlefields.
If you are far away from a hospital or a clinic and you can't get good medical care right away, and that soldier has a wound, could you apply that hydrogel directly to the wound site and begin to treat any infection that might be coming on? What about in space, though? What if we are far away from Earth's surface, on our way towards Mars, and we also have another wound on an arm or a leg, and we need a better way to treat that wound and make sure it doesn't become infected? So Tympanogen, the hydrogel itself, is a great example of a dual-purpose technology. It's something we can use not only on the Earth, but up in space.
This research could provide previously unknown foundations for future hydrogel studies. It's a great example of how microgravity can offer new insights into systems we've already explored on Earth.
The data that we're collecting is so basic science that It's hard to find those sorts of projects at this stage. As a researcher, that's really exciting for us as well. And it's in space.
And when it gets to space, it goes into the hands of astronauts who will run the experiment in orbit. Just like training for launch, landing, and spacewalks, crew members participate in hours of scientific training to prepare them for running many of the hundreds of experiments that are ongoing aboard the space station. Ready to go to class with an astronaut? We'll take you along.
Well, a lot had changed in 11 years since he was up there. There was a new experiment, so he hadn't seen that either. They tell us, you know, hey, this is a lot easier if you just go upside down. You know, you're going to be in microgravity and this will work differently.